When people see Chappie, they're going to be really excited. You have this fully functioning humanoid, and in our lab we would be focusing on the hands, the artificial touch, the learning about your environment through touch, and sometimes we even work with just a single finger. So it really takes a village, labs all across many universities and students in the world to get to the level of technological advancement that you would see has been imagined for Chappie. So in the movie, Chappie is able to explore his environment and touch different objects of different shapes and almost immediately tell the difference between these different types of objects. And researchers are still working to develop these types of machine learning algorithms that can do what Chappie does and what babies can do, frankly, so easily. Tactile sensor technology now can measure pressure, vibration, skin deformation, not always in the same sensor. But taking those raw voltages, for example, all the way to high-level percepts of shape and texture, we're still working on that. So in the movie Chappie, you'll see that he's exploring his environment and almost immediately can tell the difference between different types of objects just by touching them. And we in the lab are still working very hard towards that. Tactile sensor technology has advanced to the point where we can measure whether things are soft or hard, rough or smooth, round or pointy, for example. We still have a long way to go to get to human capabilities, but that's one of our long-term goals, is to enable the functionality of the human hand with silicon and metal. Our lab is dedicated to improving quality of life by enhancing artificial grasp and manipulation, especially in human-machine systems, where maybe you have a machine like a neuroprosthesis that's physically attached to you, or mounted to the wheelchair that you're in, or even teleoperated for bomb defusal. Anywhere dull, dirty, dangerous that you don't want a human to go, but you want a human to be able to physically, with robot hands preferably, manipulate their world. So one of the things that you'll see in Chappie is you have this fully functional robot police force that has been integrated into society. And this is one of the grand challenges of robotics, is to take these robots that were developed in the 80s for very structured industrial environments where there are no humans allowed and the robot just does its thing. And now we're plucking those robots out and putting them into the real world, out in the streets, in your homes, in hospitals. And that's one of the challenges that we face, is how to integrate robots both socially and physically with humans in the real world. So Chappie is this conscious, self-aware robot. And I think a lot of people are developing, including ourselves, artificial intelligence for robots. I think that there's no stopping that. It may be beyond my lifetime when that happens. And I think that the ethics really need to come into play. If people are going to be developing self-aware entities, it kind of needs to be done carefully, ethically, and with compassion, just like how a parent would raise a child. It's not just about the nature, it's the nurture. When designing robot hands, I think function is the most important aspect, but of course there is form, and we don't have to design hands that look like human hands, but the reason that we do is because we're inspired by the biology, and especially for neuroprosthetics. Most people tend to like hands that have the 5 fingers, the shape of the human hand, as opposed to a hook. Well, it's really hard to ignore the amazing things that biology has given us. I mean, if you look at the human hand, you've got 17,000 mechanotransducers in a single hand. You've got 2,000 in a single fingertip. And that richness of sensation, pressure, vibration, skin deformation, pain, temperature, I mean, it's multimodal. You can't get that amount of rich information from artificial tactile sensors just yet. We're getting there, we're getting closer, but artificial touch has a long way to go.